I would like to solve this question that uses total probability theory and Bayes' theorem for its solution. It was my 20th birthday. The whole family got a big gift for me and they hid it for a week. With probability 0.4, the present was hidden by mom. With probability 0.35, it was hidden by dad. And with probability 0.25 by grandma. When mom hides the present, she hides it upstairs 70% of the time and downstairs 30% of the time. Dad is equally likely to hide it upstairs or downstairs. Grandma always hides it downstairs. What is the probability that the present is upstairs? Given that it is upstairs, what is the probability that it was hidden by grandma? Okay, so let's see what we have in here. Let's define U to be the event that the present is upstairs. Let M be the event that the present is being hidden by mom. It's being hidden by mom. Then D be the event that the present is being hidden by dad. And G be the event that the present is being hidden by grandma. Okay, so based on these events, let's see what we have. With probability 0.4, the present was hidden by mom. So probability of M is 0.4. With probability 0.35, it was hidden by dad. So the probability that the person is hidden by dad is 0.35. And with probability 0.25 by grandma. So probability of G is 0.25. Great. What else do we know? When mom hides the present, she hides it upstairs 70% of the time. So probability of the present is upstairs, given the fact that it was hidden by mom, is 0.7. And it is downstairs 30% of the time. So which means what? The probability that the person is not upstairs. Okay, so I'm gonna use UC for that, even complement of U, that the person is downstairs, given that it was hidden by mom, is 0.3. Then it says that dad is equally likely to hide it upstairs or downstairs. So probability of the person is upstairs, given that it was hidden by dad, is 0.5, and the probability that it is not upstairs, or basically it is downstairs, given that it was hidden by dad, is 0.5. What else? It says that grandma always hides it downstairs. So what it says that the probability that is upstairs, given that it was hidden by grandma, is 0, and the probability that is downstairs, given that it was hidden by grandma, is 1. Great. So what are the questions? What is the probability that the person is upstairs? So it asks for probability of U. Given that it is downstairs, so it is not upstairs, it's downstairs. What is the probability that it was hidden by grandma? Okay, so P of U and P of G given UC are the questions. Now I want to find the probability that the present is upstairs, P of U. Let me give you a recall of total probability theorem, which says that if we have a sample space omega and we have some events that partition or sample space, and the events here would be M. The person is hidden by mom, by dad, and by grandma. And if we have kind of an arbitrary event like U, then probability of U is probability of U intersection with M, U intersection with M, which would be this area, plus probability of U intersection with D, which would be this area, and plus probability of U intersection with G, which would be basically this area in here. And as you see, since these areas, these intersections are disjoint, we can add the probabilities. And for each one of these intersections, I can use the conditional probability. How? Let me give you a recall of conditional probability. If you have P of A given B, then it would be P of A intersection with B over P of B. This is the conditional probability of A given B. Now, if we have the intersection, I can use the conditional probability to find the intersection. How? I'm giving a denominator 1 for probability of A given B. Let me write it like this. So probability of A given B over 1. And then I'm going to use cross multiplication. And I'm going to say that 1 times probability of A intersection with B would be probability of A given B times probability of B. Great. So for each one of them, I can write probability of U given M times probability of M. About for the second one, I can use probability of U given D times probability of D plus the last one, probability of U given G times probability of G. Now let's see what kind of information, which one we have. So probability of U given M, we have it. It's 0.7 times probability of M, which is 0.4. 0.4 plus probability of U given D is 0.5 times probability of D, which is 0.35 plus probability of U given G is 0 times probability of G, which is probability of G is 0.25. It's 0.45. Now I want to find the probability that the person was hidden by grandma given that it is downstairs. So I'm looking for the probability of G given UC. How can I find this one? As you see, in all the information that I have probability of U given MD or G, or the complement of that, probability of UC downstairs given MD or G. So this one, the question is kind of backward. Probability of the person was hidden by grandma given that it's downstairs. How can I find this one? I'm going to use Bayes' theorem for that. But first, before I go to Bayes' theorem, let me write definition of this conditional probability. It would be probability of, let me turn off this one. So it would be probability of G intersection with UC over probability of UC. Okay. Now, what is probability of G intersection with UC? I look at here, I see that I have probability of UC given G. Now, this is Bayes' theorem. So, with Bayes' theorem, I'm going to use kind of this trick. I'm going to write this intersection using the conditional probability that I learned from before. I'm going to write this as probability of UC given G times probability of G. This one is basically I'm using the definition of conditional probability on this one, and then I'm use the cross multiplication to find this one, right? And then probability of UC. Great. Now I know this information. It's just because probability of UC given G, it's given actually. It is 1 times probability of G is also given is 0.25. Then probability of UC, probability of the person is sitting downstairs is basically the complement of P of U, right? It's 1 minus probability of U. And basically, I computed this one from before, the previous one. So this is 1 times 0.25, which would be 0.25, and then 1 minus 0.455. And the answer for this one is 0.459. So with the probability of 0.45, this person was hidden by grandma if I found it downstairs.